Alrighty, today we are doing Learning Target 6.2 solubility rules, and within this we're going to be looking at double replacement. So the first thing that we have to talk about is what solubility is. So solubility is the amount of a substance that will readily dissolve into a given amount of solvent. So for example, sodium chloride, NaCl, table salt, will very easily dissolve into water. So that is solubility. So if something's soluble, it dissolves. While if something is insoluble, that substance does not dissolve in the solvent. So it remains solid. And we remember that we call solids in solution precipitates. So really that's what we're going to be looking at today in this video. So with double replacement reactions, we know we have two things that switch. So which is insoluble and which is soluble? So we don't know, and you guys do not have to memorize this by any means. That would be rather cruel if I had to made you guys memorize this. So you do have this in your reference packet. It looks like this. So these are your solubilities in your reference pack. This is going to be on the back of your handout. So this is where we're going to go to in this section. So when we are writing double replacements, what we do is we add AQ to represent something's aqueous, so that it dissolves, and we have a little subscript S to represent solid. So if we're looking at sodium chloride and lead oxide react to form lead chloride and sodium oxide, we know that chloride and the oxygen switch places to make it a double replacement. So we're going to add some prefixes. Now if you notice these prefixes right here, that tells us what is soluble and which is insoluble. So when we're doing this, we have to predict the products. So predicting the products is a little bit tougher, but the key is to look for something that is insoluble. If it's insoluble, we're going to have a reaction. That's the key. So we have sodium sulfate and barium chloride, both in solution. So the first thing we have to do in this situation is we have to write out the reaction. So sodium sulfite, we know sodium's Na, charge of +1, charge of -2, SO4, as we cross and drop, plus barium chloride, BaCl2 plus 2 plus 1. So when we're going through this, we know that the chlorine and the sulfite are going to switch places. So we know that barium is going to go with sulfate. Now with this, still remember to use your cross and drop. We have a ratio of 2 to 2, so there is no need. And we also have sodium chloride. Now we have to determine which one of these is soluble and which one is insoluble. So we look at our reference packet, and we know that all chlorides, bromides, and iodides are soluble, except silver, lead, and mercury. So we're looking for which one of our products applies to are soluble or insoluble. So when you're looking at these, some things that you have to look at are the exceptions. So if you notice, all sulfates are soluble, except calcium, strontium, barium, mercury, lead, and silver. Well, lucky for us, we have barium sulfate over here. So we know that that one is insoluble. So we know that this is a solid and this is aqueous. Now, this is something that you might be able to do on your own. You know that sodium chloride is soluble in water. Therefore, you can assume that barium sulfate is insoluble. Now we have one more part to this, and this is called the net ionic equation. Now with net ionic equation, all it does, it shows the ions that take place in the reaction. So instead of giving you all of the reactants, it breaks down into charges and shows just the ions that took place. Because when we have sodium chloride in water, it's going to separate, it's going to dissolve, because like dissolves like, and because water is polar and sodium chloride is polar as well, we're going to have Na plus and Cl minus. So these two, they're going to separate in water. So this allows us to emit the spectator ions that remain soluble throughout the entire reaction and just write the meat of the problem. So let's do an example together. So we're going to look at the same one. So we know that sodium sulfate plus barium chloride gives us barium sulfate and NaCl. Now we're going to go through and decide what is soluble. So this is soluble, 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 and here is our solid. So with net ionic equations, what you want to do is you want to find your solid and then write the ions that make up that solid. So we have sulfate, SO4, and the charge on that, because we care about the ions, is -2. Because ions, remember, we have a charge. Plus, the other part of that is barium, +2, yields barium sulfite solid. Make sure you guys can see that. Barely. Sorry about that. So that is how you do net ionic equations. So here's another example. We have silver nitrate and potassium chloride. They're going to react to form silver chloride and potassium nitrate. Well, potassium nitrate is soluble while silver chloride's insoluble. So here's our solid. So we're going to take the ions from there. So we have silver +1 and chlorine -1 forms silver chloride. So we would say that our spectator ions are potassium and nitrate. They don't go in the net ionic equation because they're just spectators. They're just sitting back and seeing the show happen. So go ahead and do these two on your own. I will check this tomorrow in class.